OPG's current nuclear stations at Pickering and Darlington are located in Durham Region. They provide nearly 30% of Ontario's electricity needs and are among the cleanest and safest in the world. Pickering Nuclear started generating power in 1971 and Darlington Nuclear in 1991. Together, they are capable of generating almost 7,000 megawatts, which is enough electricity to power a city of 3.6 million people. And yet, they produce virtually none of the emissions that cause smog, acid rain, and global warming. Our nuclear stations play an important role in helping to protect the province's environment. These benefits make nuclear an important component of the province's electricity supply, meeting its needs well into the future. OPG's nuclear generating stations are located in areas close to a large supply of fresh water for cooling and in proximity to Toronto and the GTA, which have a large demand for electricity. We understand that our friends and neighbors sometimes have questions about our stations. Nuclear power may seem like mystifying magic, but the basic concept behind it is really quite simple. In fact, a nuclear reactor is much like this kettle. The idea is to heat water to produce steam. It's exactly the same principle found at fossil fuel plants. But instead of burning coal or natural gas to produce steam, in our reactors, water is heated by the energy released from splitting natural uranium atoms, turning ordinary water into steam. The steam spins a turbine. The turbine then drives the generator, which produces electricity. The key to the nuclear reaction is unlocking the heat energy in atoms of uranium. After being mined, the uranium fuel is formed into pellets and placed inside sealed metal tubes. These tubes are welded together to form a fuel bundle, which is placed inside a large tank called a nuclear reactor, also known as a calandria. Just one of these bundles contains the same amount of energy as 400 tons of coal, or 2,000 barrels of oil. In OPG's nuclear reactors, we use a moderator to help harness the power of uranium. We use heavy water, a special kind of water, to surround the fuel bundle and slow down or moderate tiny particles called neutrons, so that they become more likely to hit and split the uranium atoms. And when these atoms split, they give off heat. A chain reaction of atom splitting ensures a constant source of heat to heat the heavy water surrounding the uranium atoms. A byproduct of the reaction is the release of energy in the form of radiation, which occurs naturally as the atoms undergo changes in their structure. The heavy water also has another job. As it is pumped through the reactor in a separate system, it heats up. It's then piped through a boiler where it turns ordinary water into high-pressure steam. That steam spins the turbine that drives the generator. OPG's reactors are designed, built, and operated using a strategy called Defense in Depth. That means even the safety backup systems have backups. Every reactor has fast shutdown systems, which work automatically to absorb the atom-splitting neutrons, and thus shutting down the reactor in approximately 2 seconds. OPG's Defense in-Depth strategy also includes its operators. They are carefully selected and trained. Operators in training must work for about 8 years under the direction of a licensed, authorized nuclear operator before they can qualify for their own license. And to obtain that license, operators must also pass stringent examinations set by the CNSC, the Canadian Nuclear Safety Commission. That's the federal agency that regulates and monitors Canada's nuclear industry. Nuclear operators are lifelong learners, dedicating 20% of their schedule to ongoing training. Our commitment to training also extends to every single person who works at one of OPG's nuclear power stations. OPG is proud of its systems and its people who ensure the safe operation of our nuclear facilities. And you don't just have to take our word for it. CNSC has its own independent inspectors on site, and it constantly monitors every phase of our operations. As well, OPG reactors are given regular checks and inspections by international agencies, such as the International Atomic Energy Agency and the World Association of Nuclear Operators. Our goal is to consistently meet or better every independent standard. That commitment to excellence also extends to how we handle radioactive waste. We have safely and securely stored every used fuel bundle right where they were produced, on the station property. First, the used fuel bundles are placed in special concrete pools where they cool off. After about 10 years, they are transferred to a dry storage container where they can be stored for decades. It's made of steel and reinforced concrete that's welded shut for an airtight seal. Through our waste management processes, not a single gram of radioactive material has ever been released. Meanwhile, OPG is working with the federally mandated Nuclear Waste Management Organization on a program for the long-term management of used nuclear fuel, as well as low and intermediate-level radioactive waste. And to make sure that there will be no financial burden on future generations, OPG each year contributes money to a segregated fund to be used exclusively for the future costs of decommissioning nuclear plants and storing their used fuel and low and intermediate level waste. To put things into perspective, current Canadian Nuclear Association statistics suggest the total amount of used fuel produced from all of Canada's nuclear power plants over the past 50 years could be stored in 6 hockey rinks up to the height of the boards. All waste management facilities are licensed and regulated by the Canadian Nuclear Safety Commission, CNSC. The CNSC regulates the use of nuclear energy and materials to safeguard health and the environment, to ensure safety and security, and to respect Canada's international commitments to the peaceful use of nuclear energy.